SSTV or slow scan television is a mode of sending still pictures by amateur radio operators. Unlike analog broadcast television, which requires a bandwidth of 6 MHz for transmitting 25 frames per second, SSTV requires a bandwidth of only 3 kHz. But it is much slower and takes much longer, about 2 minutes, for transmitting a single image frame. SSTV has been used by amateurs on HF, VHF and UHF bands. An important SSTV transmission event from International Space Station is coming up, and that is what prompted me to have a look at this mode of transmission. As per the information posted on our LEO satellite repeater group, the event will start on 3rd October 2023 at around 1440 UTC and end on 5th October 2023 at around 1815 UTC. The transmission will be on downlink frequency of 145.800 MHz and is expected to be in PD-120 SSTV format. As the SSTV transmission from International Space Station is usually done with a powerful radio having 25 to 50 watts of output, it is mentioned that it can be received easily by a handheld VHF amateur radio. Decoding can be done using the Robo36 SSTV image decoder available as free download on Google Play. All you have to do is to keep the phone with the app open in front of the speaker of the radio when the transmission is being received. As it is there for a couple of days, I think that one will have enough chance of receiving the SSTV image. Past timing of the International Space Station in your region can be obtained from the Argentinian AMSAT webpage, which also provides live information for Doppler tuning. Directional antennas and antenna rotators, though useful for receiving a better signal, may not be needed for a good elevation pass, as the signal is quite strong with a higher power output. Among the vertical antennas, ground plane antenna and slim jim antenna with higher angle of radiation are likely to be better than the long collinear antennas, which have a low angle of radiation directed at the horizon for terrestrial communication. Today I installed the Robo36 SSTV image decoder app from Google Play on my Android phone and decided to test it out using test recordings available at AMSAT UK webpage. I used the MP3 test recording of a PD-120 transmission by John Breyer, KG4 AKV. Before the MP3 file was played, the Robo36 was slowly displaying a green screen as shown here. Once the MP3 file link was clicked and the phone kept near the computer speaker, the app started decoding the image. Sound heard from the speaker is like the usual buzzing type of note heard with the digital transmissions, of which FT8 would be now familiar to most amateur radio operators. Earlier, one would have expected amateur radio operators to identify it as an RTTY signal. This was the image displayed on my phone. While using the Robo36 app, there is provision for selecting PD-120 from the settings. Earlier, it was PD-180 and the transmission time was 3 minutes, while with PD-120, it is only 2 minutes. So they say that you can receive up to 3 images during a single pass of the International Space Station. After every 2 minutes of transmission, there could be an off time of 2 minutes. 3 images can be received only if you start getting them at the very beginning of the pass. Otherwise, it may be only 2 images. As the schedule is likely to be over 2 days, multiple suitable passes are likely to be there in each region, and at least some of them will be good passes. So let us try out this SSTV event to the maximum.